Hello, my name is Andrzej Bialecki. I'm going to talk about portable Lucene index format today. First, let's start with more or less who am I. I've been involved in Lucene, in the Apache Lucene project for quite a while, and both as a user and as a developer. I'm also involved in several other Apache projects, mostly those that deal with big data and search. I'm currently working also as a developer at Lucid Imagination. One project, my pet project that you may be familiar with is the Look, the Lucene Index Toolbox. Some of you may have used it in the past, or in the present, or in the future. So what I'm going to cover is the challenge that we are facing, which is the data compatibility challenge, and how this idea of a portable index format tries to address this challenge. And I'm going to cover also a little bit of design and implementation, and illustrate this with some use cases or possible applications of this format. When it comes to the Lucene index format, as you may or may not know it, it's mostly binary. Which means that it's not directly human readable, at least not for an ordinary human. If you can read this, this is a norms file. And this one, this Q corresponds to 0625. I'm not kidding, I looked it up. I can't read it right now. So the reason for binary formats is, of course, that it's highly efficient. The bottleneck in every search application is the I/O, the speed with which the data can be pulled in from the disk and decoded, that's the other bottleneck, and processed. So if we can come up with a format that is highly efficient for random seeks, random access, then that's the better, right? It needs to be highly compressed, efficiently compressed, and you won't find any general purpose compression algorithms in Lucene. All of the compression algorithms that Lucene uses are specifically tailored and finely tuned to the nature of data that we work on. So, for instance, the postings in Lucene trunk are compressed, for example, with an algorithm called P4 delta, which is not a general purpose compression algorithm. The other point that is relevant to this presentation is that this format is very strict, very well defined. Every bit counts. It's not all the same that this or that bit is 0 or 1. If you try to use some other version of Lucene, and this bit is 0, everything will crash and burn. So now we come to the core of the problem. What about backward compatibility? Is it possible to use data that was produced by other versions of Lucene with another version of the library? Well, it is, and it's not. There is some limited compatibility built in Lucene. First of all, there are two major areas of compatibility. One, when it comes to the APIs. And here we sort of have a well-known mechanism in the APIs of planned obsolescence where we use the deprecation annotations. What goes inside, behind those deprecated methods, you probably don't want to know it, because it's sometimes so hairy that it scares even the core committers. Ask Uwe what it took, or Robert, what it took to re-implement preflex codec, for instance. So that's the second point. The compatibility of data, dealing with data in older formats, is extremely complicated for many reasons. It's both complex and costly. It requires top-notch expertise. It requires a developer that is familiar both with the old format intimately and with the new format. And there are just, like, I don't know, 3 or 4 people that can do this. Barely. So, however, this support is crucial. This limited amount of backward compatibility is still crucial for upgrades. When you upgrade your library to the next release, you kind of expect that you should be able to read the data that is already there. It's not always the case, unfortunately, even with the best efforts of Lucene developers. Because sometimes there are incompatibilities that are very difficult to cover with this back compatibility code. Like, for instance, you use a different analyzer that uses a different sort of policy of splitting, like the so-called standard analyzer. There was a change in how it dealt with certain types of tokens. And no matter if how much code you implement for reading back the old formats, the data is not there. So, well. Even worse, when the situation is even worse when it comes to forward compatibility, and that's actually very easy to explain. There is none. Forward compatibility means that you have an older version of the library, and you want to read the data produced by the newer version of the library. That's simply not possible with Lucene. And for good reasons. I mean, there are compression algorithms that were not available at the time of Lucene 2.4, let's say. So you may wonder, what is the time span? How long do I really need all data? Maybe I don't need it anymore. Maybe I can just trash it and reindex from scratch. In most cases, that's the right answer. You should be aware that there are so many traps and so many dangerous and difficult situations that you should be prepared to reindex from scratch. That's most of the time, that's the best answer to the backward compatibility of data. However, there are still situations in which you may want to keep this data around for a longer period of time. Like, for instance, with backups. Still, even though in most cases the index is not your system of record, how many of you are familiar with this term, system of record? Okay, not so many. System of record is a term coming from data warehousing, which means it describes a system that is the canonical source of data. In many environments, this would be the database, like the customer database or something, right? This is the system that you can always refer to and get the data in the most canonical form. And you know that this data is full, complete, as much as it can be. In many cases, your search index is not the system of record because you have this data somewhere around. You do some post-processing, ETL sort of pipeline, and then you end up with the search index, right? But still, there are situations when you may want to keep this index around for a longer period of time. You may need to do backups. Like when you upgrade your search cluster, if something goes wrong, of course you want to be able to roll back, right? Or if building an index takes a long time, or it takes a major effort, like you have to crawl this or that site which is very slow, or you have to process this database, use a lot of CPU for NLP processing, etc. In short, it's costly. You may want to keep certain data that doesn't change too quickly for a longer period of time. What happens if you have to upgrade Lucene library like 2 releases ahead? Well, you're in trouble. Or you may want to keep this data to validate some claims or to prove compliance. Like, oh, did you really sanitize your data to remove this 3-letter acronym of our agency, no matter what agency it is? Or to test performance across releases. That's another valid purpose. Even worse, if you have to keep this data around for a really long time, like years. There's really no provision in Lucene for reading really old formats unless you actually use old versions of Lucene. But this quickly becomes a major exercise in archaeology. I mean, how many old versions of old environments you want to keep around? That's not practical beyond a certain point. So you could say it's an m times n problem. You have m versions of Lucene and n versions of Lucene that are source and targets, and then you want to sort of figure out what kind of compatibility, data compatibility you want to have between these versions. It turns out that Lucene currently supports only very limited length of this compatibility, usually at most 2 releases back, usually even less, which means 1. Like in the case of Lucene 4. If you add to this that the cost of maintaining this code is really high, then it becomes an issue. Even higher is the cost of broader backwards compatibility and forward compatibility. As I said, there is none forward compatibility in Lucene. You simply are not able to read new data created with new versions with older versions of the library. Is there some conclusion that we can draw from this? Well, you should be prepared to suffer if you want to keep this old data around. There should be some better solution for this, and that's what I'm going to explain. Are you familiar with this picture? Cool. Are you familiar with this picture? That's the mini USB connector. That's one of the few things, I might say critically, but one of the things that European Commission got right. They ordered all mobile phone manufacturers to introduce this as a standard for the chargers, for the mobile chargers. Okay, but the question is, can we come up with one simple, flexible, and generic format that can encompass basically all kinds of data across all major versions of Lucene? If we can, then sort of this backwards and forward compatibility problem solves itself. So we would like to see something that would allow us to implement this compatibility layer once, from a specific version of Lucene to this portable format. We hope that it will reduce costs of long-term maintenance and will reduce the cost of implementing these very specific backward compatibility layers. It will offer long-term readability, and it would be nice if this format allowed also for processing with very simple tools. If you have data that is like 10 years old, probably nobody alive knows how to process, how to read this data. Do you still use 8-inch floppies anywhere? Okay, Carl uses. Anyway, you see, if you think in the time span of 1 year, things are still manageable. If you think in the time span of 5 years, things become much, much less manageable, even with these physical formats like floppies. So it should be easy to process with simple tools. It should be extensible because we want to encompass new features as they arrive, as they appear in Lucene. But the counterpart of this, it should be reducible, meaning that, okay, we have new data created with new library, and we should be able to extract some relevant portions from this new data so that we can still apply it to the old version of Lucene. Sounds like fantasy, right? The way to do it, I'm going to describe the implementation in a moment, so that's doable, believe me. The way to do it, to approach this problem, is to focus on function and not on the implementation. If you think about what kind of data is kept in Lucene files in Lucene data formats, the meaning of this data and the logical structure of this data hasn't changed really so much across the last 7-8 years. What changed are certain options, certain flags, certain records or parts of data that were not available before or are encoded differently right now in newer versions than the way they used for encoding in older versions. So the logical data model in Lucene more or less stayed the same across all major releases, which is good. So this format should focus on function and not on the implementation. It should be relaxed and forgiving, meaning that if I encounter a flag that I don't know about, I should not crash. I should just skip it or figure out a sensible default. It should focus on clarity and not on minimal size. As I mentioned, the binary formats are, of course, focused on getting data in as minimal space as possible and as efficiently as possible. That's not our goal. Our goal is portability. So we can denormalize data and maybe have repeated sections of data if it helps portability. For example, in some cases, it might be useful to separate term dictionary from term frequencies or postings from payloads, even though in all implementations up to date, these two data, postings and payloads, reside in the same physical file. And the format should allow for a simple metadata per item and per section of the index. Speaking of sections, maybe I should explain it. That's basically the model of the index as you know it. There is nothing strange in it. It just presented in a more abstract way, separated from implementation. So you have the global data per index, which includes like source format details, list of commits, list of index sections like segments, shared doc stores, whatever else. And then you have the segment sections themselves. So you have, in turn, nested information, nested structure in these segments. Right? You should be all familiar with this. I'm not showing anything strange. You have segment 1, segment 2, etc., each containing a bunch of documents. And then you have stored fields, you have terms, term frequencies, postings, payloads, term vectors, doc values, new in Lucene 4. And you have a list of deleted documents. So the main point here is that this model is valid across all major releases of Lucene. What differs are the implementation details. So this is the standard model. So why not just be more relaxed and forgiving and use some simple plain text formats to make it more portable? If the portability is our goal and not the top efficiency. Some of you may ask themselves, okay, but this sounds like a simple text codec, something that is available in Lucene 4, which basically stores parts of index in plain text format. Isn't it the same thing? Well, not quite yet. A simple text codec doesn't handle deviations from its strict format well. It just crashes, right? And it doesn't cover all the parts of the index. So that's another problem. So why not implement a sort of portable codec, which is a thing that could store all the parts of the index in this relaxed and forgiving format? Well, the codec API is not complete yet. That's the problem. I'm looking at you, Robert. So the API is capable right now of storing term dictionary and postings and segment infos, but not much else. There is a work going on extending this API to cover all parts of the index, so that we can customize the formats of all parts of the index, which is very cool and very useful for many, many reasons, not just this one. Like, for instance, if you want to store stored fields, not in a file, but in a NoSQL store, right? Then you would customize the stored field codec or whatever it's called. Or if you want to implement a more efficient storage for term vectors, which is currently kind of not that really efficient. So eventually, this codec API will make this portable codec possible, but not today yet. And of course, we should reuse the code that is already there. So I'm not against simple text codec, even though the primary purpose of this simple text codec is just for debugging and just casual interest purpose. But it is useful. It is useful. It helps it helps you to understand the structure of the data in Lucene. And occasionally, if it's a one-off error, you can go with VI or Emacs or Notepad, and you can correct this error, which is kind of cool. So we should reuse and extend the simple text codec to meet the goals of this relaxed and forgiving and simple plain text format. But in the meantime, we'll have to use export and import utilities that cover all the parts of the index. Another scenario worth mentioning here is that we can scale this portable index model down to a single document. Currently, there is no way, no easy way. Well, there's always a way. It's just a computer, right? There is no easy way to add pre-analyzed documents to Lucene or Solr. Let's say you have an existing text processing pipeline, like you have an existing fast installation, or you have OpenPipe, or the Gate, or whatever, right? Any kind of major investment in text analysis pipeline. And then you don't want to throw it away and re-implement it on top of Solr. That's sort of wasteful. So it would be nice if there was a simple way to hook up this complex pipeline so that we can get the data that was already pre-analyzed, pre-tokenized, tagged, and whatnot, exactly in the same way directly to the Lucene index. There is a sort of hack that I implemented once, which is called pre-analyzed field. That's in Solr 1535, which allows you to format your field in a special way, and then basically it's a serialization format for a token stream. So you can submit a token stream, and then it will get indexed exactly as it was submitted. But it's still kind of limited to a single field and a single document and single document, right? So it's too limited, and it doesn't cover all the features of a fully inverted and fully analyzed document in Lucene. So we could come up, if we scale this model down to a single document, we could come up with a portable format that represents a single fully inverted document, fully analyzed, fully tokenized, with all the structure that you expect in the index. Just, it's not a standalone index, it's just a single document. When it comes to the term dictionary, maybe we just need term vectors. We don't need a full term dictionary. We can figure out term dictionary from term vectors. So another relevant point here is that since we would use simple plain text formats, this document, this fully inverted document, would be easy to construct using non-Lucene tools, like these existing external pipelines. So that's the major use case for this sort of portable format. Other ideas, I don't know, transaction log. Maybe we don't want to repeat the analysis steps in the transaction log. The transaction log is a feature that is being right now added to the Solr cloud. Yannick will talk about it tomorrow, I guess. No? Or someone else? Mark, okay, yeah. I knew someone would talk about this. So the transaction log stores the latest additions to the index without so that it can be replicated across shard servers. So currently, this transaction log stores raw Solr input documents. Maybe it should store post-analysis documents. So we isolate ourselves from configuration differences in shard servers, and we don't have to repeat the text analysis as many times as there are shard servers. Just an idea. Or maybe we can use it for fine-grained shard rebalancing, or for rolling upgrades where we have different versions of Solr across the cluster. I'm sure there are some other ideas that you can come up with. So that's when it comes to the model. What about the serialization format? Well, as I mentioned before, it should be generic enough. We want to express all the existing data types that we know about, and it needs to be flexible enough to cover all possible future, or at least for some foreseeable future data types. On the other hand, it should be specific enough, so the things that we know about, like postings, well, postings are present in every version of Lucene, right? So there should be some predefined section of this portable format that says, yeah, these are the postings. And it should be designed so that it has very well-defined record boundaries. So if you don't know a record, you can skip it. That's the whole point of forward compatibility. You have a data in a newer format, which has some magic in it, and you can skip this magic and still extract the parts that are relevant to you. It should be easily parsed and only reasonably efficient. Efficiency is not the primary goal here. Portability is. Normally, a Lucene index is a bunch of files. So it would be nice if it were just a single file if you want to ship it, right? Well, this container format, maybe it could be a zip, or, but there are some limitations to the zip format, so it's not practical. Or it could be just a Lucene directory, and if you really want to have a single file, you can zip it, or you can tar it, or you can whatever, concatenate it. Again, it should use simply plain text formats. That's what I covered already. One interesting twist to this is that avro is a project that came out of the Hadoop family of projects. And it's a library for serialization of data. But the interesting part is that the serialization itself contains the schema. And there are very simple tools to read the schema and reconstruct the data based on the data schema. So that would be a nice thing to explore when it regards to this format. It would be definitely more efficient because it can be expressed, again, in binary, but self-describing. So based on these requirements and goals, I went and implemented a preliminary patch, which is sort of working, but I wouldn't put it in production yet. So there is an issue created, Lucene 3491. There is a code there. You can download it, you can try it out, and you can see for yourself whether it's useful, applicable, or what. There is a portable codec implemented there, just as a proof of concept. The reason it's a proof of concept is because codec does not cover all the parts of the index. So there are still some leftovers that need to be processed manually. So the full coverage is implemented in this portable index exporter tool. Some of you who use Look may be familiar with the XML export function that is implemented in Look. Actually, there have been quite a few people asking me about this functionality. Apparently, it is useful in some scenarios. So the XML exporter in Look has one big disadvantage. It saves only what it can meaning that it saves only, it exports only stored fields and some overall statistics about the index. This portable index exporter tool exports everything, including postings, payloads, whatnot, whatever you can, and doc values even. So it mimics the expected data from portable codec once codec API covers everything. And the serialization is just a bunch of files in a directory. So, for example, I went and implemented a test, a unit test. You're supposed to, so that's what I did. And I was curious how it works. So that's an output of a unit test. It's an index in portable format. So you see, it is kind of similar to the regular index, right? You have different sections, and you have these mysterious meta files. Let's take a look at them. So, for instance, index metadata. Well, you could have user data. I had no user data here. But you have field names, number of documents, number of readers, meaning number of subreaders, meaning number of segments in this case. We have the information about the segments. This is kind of tedious, so it's basically the same information, only in greater detail. You see, there is some redundancy and some denormalization of data that I mentioned before. We are not after the most compact format. We are after portability and reusing bits and pieces wherever we can. So, for instance, you can see that there is one segment, size equals 1, and its name, the name of the 0th segment is _0. Then there is the information about commits. There is just one commit which is not deleted, and it's recorded in the segments _1 file in the original index, and it consists of these files in the original index, if we're interested. The information about fields. If you ever used look4, you will recognize this extended format for the flags. Basically, it says, okay, this field is indexed with documents, frequencies, and postings. It has term vectors with offsets and positions. It uses norms. It's not a binary field, and it uses doc values that are encoded in floating point 64 bits. Right? Similarly, here you have a pure doc values field. I don't know what is the reason why it says it has norms. Maybe that's a bug in doc values. And it uses variable integer format. And then, of course, you have the stored fields, which in this case are kind of simple. This is a test. But it points out, OK, these are the docs, these are the fields, and this is the type of the fields. If it were a binary field, we would have a hex, basically hex string of the binary. We have a term dictionary, field 1, term A with frequency 2 and total frequency 2, and we have term doc, term that is named doc, right? That's the value of the term, frequency 1, total, etc., etc. And this is, again, another example of this denormalization of data. We could have exported everything like the simple text codec does, including the postings, but we don't. We denormalize this data because there might be some users that it's easier for them to just consume the term dictionary and just skip the postings. And we have postings here as well, right? So we have field 2, field F1, term A, doc 0 with frequency 1, and at position 2, etc., etc. We have term vectors. For doc 0, field 1, we have term A with frequency 1 and at offset 8 to 9, and positions, just one position, position 2. And doc values, field F2 uses a floating point 64 bit, right? And there is no value for document 0, which should be just null, I believe. But currently, it's presented as 0 by the API. And for document 1 is something, right? Then we have field f3 with variable integer encoding and with this suspiciously round number. OK, so what is the current status of this implementation? Well, this portable index exporter tool works. It will export every data that you can imagine from your Lucene index, and will encode it in these simple text formats. So this part is already usable as a kind of archival tool. There is no corresponding import tool, so this back compatibility is not realized yet. And the codec-based tools are incomplete because the codec-based API is incomplete. So there is still some work to be done here. And if you have some spare CPU cycles, I welcome you. I mean, I will continue dabbling at this, at least on the exporter and importer tool. And whenever codec API grows to cover all the parts, I will re-implement this tool using the codec API. But any help is welcome in the meantime. So to summarize, we saw that the data portability, especially across longer time spans, is a challenge. It's difficult to keep around older environments and difficult to use newer data with older environments. So long-term archival is also a challenge. The solution to this is to use simple data formats that don't require very sophisticated tools to process. And I explained how this portable index format idea works and how it's implemented currently. And it enables extensibility, meaning that you can add new stuff as new formats come out. It's reducible so that the older versions should be able to read it. And it enables sort of this pipeline integration with external systems. And this portable codec and portable index exporter tool is my first attempt to realize this goal. More details in this Lucene issue, and thank you very much.